angles of measurement. All right? It's nothing crazy hard. Just don't overthink it. All we're really talking about is if I'm facing you and I turn 360 degrees, I won in one full revolution, right? If I turn 180, I'm here. All right, the only thing we're going to add to it is positive and negative. That's going to tell you what direction I turn. Because if you tell me to turn 180 degrees and you want me to go this way, you have to somehow tell me to go left or clockwise, counterclockwise. With angles of revolution, we're going to use positive and negative to tell me which way to turn. And let's go ahead and get into it. All right, measures of angles. Degrees. We've used these all the time in geometry. We've talked about degrees with triangles. We have a 90-degree triangle, obtuse, acute. Well, standard form of rotation angle. In trig, the initial side of the angle lies on the positive x-axis, and the terminal side rotates counterclockwise for positive, so counterclockwise for positive angles, and clockwise for negative. And I'll just tell you what I mean by all of that right below. So if you're confused at all, we'll clear it up. We have to have a starting point. Because if you close your eyes right now. Everyone. All right, now look up. How far did I rotate?
Nobody knows.
Nobody knows. Well, I know, because I did it. I need to tell you where I started and where I ended. You saw where I ended here, but I could have spun around a billion times this way. I didn't actually. It's just to trick you. So in math, we're always going to start at the same place. It's called our initial side, and that is along our positive x-axis. This is always our initial side. So whenever I tell you to rotate a certain degrees, you always start here and you go around, or you go around the opposite way. So in this first example, this is my initial side. And it's going to 99.9999% of the time, your initial side will always be here. All right, you will always assume this is where you started. All right, then the other side must be where we ended. We only have two sides, a start and an end point. So this must be my terminal side. That's where it terminates. That's where it ends. So this right here is our terminal side. Don't get super bogged down in these terms. Just know I start, I end somewhere. That's all I'm telling you. We start somewhere, we end somewhere. Note that all three of these start in the same place, as they should, but they all end at the same place as well, which means you would think it'd be the exact same angle, but each one's going to have a different measure. So we go back up here and we look. Notice how it's pointing to counterclockwise. I will always tell you which way it rotated. It will always have these lines on here to tell you which way it rotated. Because if it goes counterclockwise, it's going to be a positive angle. And to figure out how far it went, I mean, we can see down here it says 120 degrees. We have to remember something about circles. So when we start, we are going to start at 0 degrees. If I didn't move, I'm at 0 degrees. If I move here, just like a right angle, this will be our 90 degrees. If I go halfway around a circle, it's 180 degrees. Then it'd be 270 down in the bottom. And if I made one full revolution, I'd be 360 degrees. And this is how you kind of note 0 degrees is my starting, 360 is my ending, even though it'd be the same place. All right, this one definitely moved past 90, but less than 180. So does 120 degrees make sense? Yeah, it's not going to be perfect. If I made you just guess at this, you might guess 120, 130, 140. Just give me a realistic value if I put a line right here. Don't give me 179, because that would be obviously here. Don't give me 91. Give me something around here, all right? All right, that's if I go counterclockwise. Or, yeah, if I go counterclockwise. Now, if I ever go clockwise, that's what this arrow is showing me going clockwise on this example. That means I'm going in a negative direction. Like I said, it's just telling me am I going left or right. Negative tells me I'm going clockwise. Well, what I like to do, if you ever get confused, make sure you label it negative-wise. So if this is 0 degrees, then if I'm going the negative direction, this would be negative 90 degrees down here. This would be negative 180. This would be negative 270. And if I went all the way around in the negative direction, I'd be negative 360 degrees. So it just flips, all right, when we go in a negative direction. So now we look at same starting point, same ending point, but this time it's between negative 180 and negative 270, so negative 240 makes sense. But we had to know which direction it went and how far it went. Okay? So that everything is important. Initial side should always be the same. Look out for your terminal side and look which way it's rotating. All right, the last one looks like it's in the exact same place. However, am I allowed to look at one and then spin, and then I could spin again? Now I just did 2 revolutions, right? Same thing with angles. I can fly around in a circle, just like a clock can go all the way around a billion times. We're going to say this one goes in the positive direction, so it'll be counterclockwise. It's going to go around, and it's going to stop right there. I'm still going to write my 0 degrees, my 90, my 180, and my 270. I'm probably not going to put my, I'll put my 360. Does someone want to take a guess at what the measure of this angle is? And my hint to you is it's not 120 and it's not negative 240. We got some hands, 4, 5 hands, 6, 7. Oh, what do you got?
480.
480. How'd you get 480?
Because you went around once and then you stopped somewhere between 90 and 180.
Perfect. So we went around once, and 1 full revolution is 360, right? So we know it's more than 360. And then we're going to add on this extra part. And we're assuming it's the same distance as here. So it's 360 plus 120. So I'll go ahead and write that. Plus 120 is going to give me 480. And that is, in fact, 100% correct. Who else had 480? Who had no idea? Who had an idea but it wasn't 480? Who didn't raise their hand? It had to be one of those 3. Okay, so it's 480. It is 480. So as you can see, I can have the same endpoint, but I can have 3 different angles attached to it, and we'll get to what that's called in a second. All right, the terminal side of an angle will lie in one of 4 quadrants. Recall, I can't even say it, I'm just done, I quit. Recall the quadrants 1, 2, 3, and 4. So we have 4 quadrants. What quadrant's this one? What quadrant's this one?
3.
That's the easy one, right? Now it's, which quadrant is this one?
4.
Ooh, yeah. And that makes this one, this one's 3. 2. These are only 2 that can be complicated, because sometimes you can go this way. You should always have 1 and 3 right, every single time. Okay, so we just got to figure out where it lies. So our first one is 1,225.6 degrees. I'm pretty sure that's more than 1 full rotation. And it's positive, right? So should it go up or should it go down if it's positive? Jack? Up. It should go up. So we should go this direction, right? Why don't you see if you can figure out what quadrants it's in and come up with an idea of how we can come up with that. Just trying to figure out which quadrant it's in. Jack already told us it has to go up to start off with. We know so we know we have to start along this x-axis.
Are you talking about the end line?
Yep. Sorry, yeah. Because we're looking for our terminal side, and our terminal side is always that end. Initial start, terminal end. You already gave me an answer. But you got it?
I think so.
Okay. Probably. Did you just draw it?
Yeah.
Jack, what'd you get?
Would it be quadrant 2?
It would be quadrant 2. And how'd you do that?
I divided the 1225.6 by 360.
Ooh, let's do that. Let's do that. So we have 1225.6, and you divide it by 360. Why'd you divide by 360?
Because 360 is how many, the full rotation.
Yeah, so you're seeing how many full rotations are in there. And it came out to 3 point something something, right?
Yeah, 3.4 something.
Do you really care about the 4? We'll put 3 point something. Do we really care about the something?
Not much.
Because we really care that it was 3 revolutions. That's all I care about is 3 revolutions. Can someone help me finish this and not Jack because he did it? If I knew it was 3 full rotations, what could I do next? Yeah.
You take the leftover amount.
The something?
Yeah, the something, and then you add it to like to the last.
But it'd be a decimal, wouldn't it?
Yeah. I mean, I didn't do it like he did.
Okay. No, that'll work. If we use the decimal and multiply it by 360, then we could possibly come up with the amount. What's something else we could do?
You multiply the 360 by 3 and then take the difference of the 12.5.6.
So let's do 360 times 3. And what's 360 times 3? Did anyone do it? What, 1080? Ooh. It's almost like it's something. Isn't that snowboarding? 1080? Wasn't that a game?
Yeah.
Was that N64? Yeah. So we have 1080 degrees, and you said do the 1225.6 and subtract 1080 from that?
It is 145.6. Like the, never mind.
What does it come out to? What did you get?
Yeah, 145.6.
So that means that this goes around 3 times. So let's make it go around 3 times. 1, 2, 3. And then what I really care about is just what you came up with and what Jack probably came up with is that 145 degrees. Maybe a little further. Because we got to remember that this is 90 degrees. And this is 180 degrees. So 145 degrees, all we need to know is it's somewhere between 90 and 180, which is quadrant 2. Yeah.
So pretty much you can just think if it's greater than 90 and less than 180, it's into.
Yep. And if it's somewhere between 180 and 270, quadrant 3. Yep, 0 and 90. Yep, you can absolutely think that way. Is there any other way we could have done this?
Probably.
This is the book way to do it. Is there? How did you do it?
I just drew it.
You just drew it. You just counted like it's going to be 3 circles. Another way you could think about this is if you get bogged down in division, multiplication, and figuring out all these numbers and getting lost in it, take 1225.6, subtract 360. Subtract 360. Subtract 360 until you get to a number that's somewhere between 0 and 360. If you would have subtracted 360 from this 3 times, you would have came up with 145.6, and you would have said, hey, it's between 90 and I'm done, right? And a lot of times with calculators, this is great. This is how the book would do it. But sometimes it's just nice to in a calculator to type in a number, subtract 360, subtract 360, subtract 360, and you have your answer. Versus dividing, multiplying, and then subtracting. So although this is how the book would do it, sometimes there's simpler ways, right? Just using subtraction, addition. Like I said, this is what the book would want you to do. But me personally, if I want to do it really quick, I just subtract 360 until I get to 145.6. Done. All right, the next one is negative 95. Who can tell me what quadrant negative 95 degrees is in? Yeah.
3.
Quadrant 3. Let's see if you're right. Can I make my initial side go up like that? Can I just call that my initial side? Are we okay with that? No, you can't. Your initial side always has to be there. It's locked in stone. And if we're going in the negative direction, that means we're going down. So we must be going in this direction. So let's just mark it. This is 0 degrees. We're going negative, so this is negative 90 degrees. Well, negative 95 degrees is just going to be a little bit bigger than that. So that is definitely quadrant 3. Good work. All right, our last one is negative 225. Oh, we got it? What do you got?
Quadrant 2.
Quadrant 2. We already did quadrant 2. There's no way it could happen twice, could it? Let's see, 0 degrees, negative 90 degrees, negative 180, negative 270. We're going around, well, it's less than 270. It's greater than, okay. Looks like quadrant 2 to me. So we'll call that quadrant the dose. That almost looks like 2, right? Kind of deformed 2. It's a 2. That's a Roman numeral 2. Trust me on that. You gotta have faith that my penmanship is what I'm saying, because it won't often look like it. All right, any questions on those? Toughest one is probably this one. All right, we good otherwise? If this was negative 1225, I'd probably just add 360 until it's the negative version or whatever. All right? Just takes practice. We're going to see this circle so many times in the next few months. It's going to drive you nuts. But the good news is we're just going to start with super simple. We're just going to start with degrees. Then we're going to add radians onto it, and then we're going to add sine, cosine, tangent, and it becomes what's called the unit circle. All right, but right now we're just focusing on degrees. It's our first day. Well, we already covered most of our degrees. Let me change that to black real quick. We know that's 0 degrees. We know that this is 90 degrees. We know this is 180. And we know this is 270. Now the art to this isn't knowing what degrees there are. It's the fact that degrees is the easiest thing we have, so we have to be able to write it really, really quick. All right, your degrees should just like flow really quick. And the easiest way that I find to write it very quickly is I skip some numbers and I fill them in a second. So here's what I do. I just know the distance from here to here is plus 30 degrees. So that must mean this is 30 degrees. Then I'm going to skip a dot and say, well, this is plus 30 degrees. So that makes this 60 degrees. And we're going to follow that pattern. This is the last time I'm going to write it, but from here to here is plus 30. So that must mean this is 120. And we skip a dot and we add 30, and it's going to be 150. 150 plus 30 is 180, so we're good. 180 plus 30 is going to be 210. Skip a dot, add 30, and we have 240. 240 plus 30 is 270, so we're good. Then it's 300, and then it's 330. Now this is halfway between this adding 30. So this must mean it's 15 away. I think a lot of you probably already saw that. So from here to here is actually just plus 15 degrees. So that makes this 45. It also makes all the rest of them easy because you just add 15 here, so this must be 135. You add 15 here, so you have 225. And you add 15 to 300, and it becomes 315 degrees. I know with me describing it takes a while, but if you just do it on your own, it goes super fast. It's just good to know that little trick, Because you'll memorize all these numbers, and all of a sudden you get to a test and you'll forget them. And you'll be like, oh crap, I know there's something that goes here, but I forget what. But if you remember that 30 and 15 rule, you're back on track. All right, learn it, love it. We'll have many quizzes on the unit circle. It'll be fun. We're going to enjoy it. Coterminal angles. Coterminal angles are angles that have the same initial side, which makes sense because they all have the same initial side, but they have the same terminal side and they have a different degree value. So if we go back to our original thing, well, it's the same ones as here. Each one of these is coterminal. 120 is coterminal with negative 240, which is coterminal with 480 because they end at the exact same place, but they have a different degree associated with them. The key to coterminal angles is 360 degrees. All right? For this to be in the same spot as this, it has to be 360 degrees away from it, either positive or negative. So if I have an angle and I'm facing here and I add 360 to it, I'm a coterminal angle. If I subtract 360 from it, I'm a coterminal angle. If I subtract 360 over and over and over, I'm still a coterminal angle, but it has to be something that deals with 360 degrees. Yeah.
So does that like add up to 360?
Does it have to add up to 360? I'm not quite sure what you mean by add up.
Like the 120 and the and the negative 240.
No, not necessarily. It's just a case that they do add up to 360. The first two coterminal might be, but if I subtract 360 from this, it's still coterminal with 120. So if I went one more time in the negative direction, so if I subtract 360 from this, I get 600, which is coterminal, but it doesn't add up to 360 necessarily. Okay, we'll see here, and we'll practice it. Hopefully it's a little clearer then. But our first one is 120. This one's coterminal. So what that means is if I do 120 minus 360, because one revolution less, that just happens to equal negative 240. So that's me going backwards once, and I get back to this angle. So basically, if I start here and go backwards once, I get this angle. If I'm here, and I go around 360, that's going to give us our next one. So if I'm here, but I just happen to go around once more, that means if I take that initial angle, that 120, and add 360 to it, it's going to give me that coterminal angle of 480. If I add 360 to this, it'd be another coterminal angle. If I add 360 more, another coterminal angle. It has to be 360 though. If I add 180, it's no longer coterminal. If I add 180 to this, it's actually over here that it's going to exist. All right? So it's a series of adding 360 or subtracting 360 that gets us their coterminal angles. Yeah?
But if the angle is negative 600, it'd still be coterminal with all of the ones up.
All of them. Yep. All three of these are coterminal along with negative 600 would also be. Yep. So at negative 960. And if you keep subtracting, there's an infinite number of coterminal angles. It's just how many times you're willing to rotate this around. Like if I just kept drawing circles and circles and circles, as long as I end up here, it's coterminal. All right? I'm not 100% sure. I think I pretty much skipped this part because it's kind of... Let's skip this and I'll put a definition here in a second. I just want to, let's use some intuition on this first. Because sometimes just intuition is better than writing out math formulas. Because sometimes I write out a math formula like, I thought I got it. And then he wrote K's and M's and stuff and now I don't know what's going on. I'm supposed to find two positive and two negative angles that are coterminal with negative 50. I want to find two positive. How could I find one positive angle that's coterminal with negative 50 degrees? One person? Oh, okay. I got you. Add 360?
Add 360, yeah.
Add 360. So I would just take negative 50 and add 360, and that would be my first coterminal positive. What would I do to get my next positive coterminal? Yeah?
Subtract 360.
Wouldn't that give me a negative, though? I want to get two positives. So
Twice.
add twice? Yeah. So I would add 360 to this. That gets me my first one. And I add 360 again. That will be my second one. And then how do I get my negative two ones? Subtract. I would subtract 360, and then I would subtract 360. So let's do our positive ones. Let's do our two positive. So I would just do negative 50 plus 360, which is going to equal 310 degrees. Then we could take 310, add 360, and we're going to come up with 670 degrees. Could I come up with more positive ones?
Yeah.
What would I keep doing to get more positive ones?
Keep adding.
Keep adding 360 over and over and over. Don't overthink this. All right? It is that simple. It's adding or subtracting 360. If I want to get negative ones, we're just going to subtract 360. So 50 minus 360 equals a negative 410. And then maybe we'll do negative 410 minus 360 is going to equal a negative 770 degrees. Now, without plotting these or doing anything, I know they'll be in the same spot. All right? That terminal end will be on the same spot for all of them. All right, any questions on those? So coterminal 360. Always think 360. And it can't be close. It can't be 361. All right? All right, the next one says determine whether the angles in standard position with the given measures are coterminal. Can someone tell me whether they think these are coterminal or not? And I'll wait. Did you answer already? No. I don't know. Go.
But there's, yeah, the first one is because there's a differential of 360.
There's a differential of 360. If I go 190 and subtract 360 from it, it turns into negative 170. Easy enough, because you can subtract and add 360 once again. Let's say it's huge. Let's say I give you like 12,836,000, whatever, some huge number. All right, and you don't want to subtract 360 over and over and over again. The way we could check to see if this works, we can do negative 170 must equal our initial angle plus some multiple of 360 degrees. And this number must be a whole number. It could be negative or it could be positive. This number is going to tell me how many rotations it is away. All right, if it's 1.1, it's more than one full rotation. If it's 2, it's 2 full rotation. So if we go ahead and solve for this, we're going to see this is going to come, we're going to subtract 190 from both sides. So we have negative 360 equals k times 360. Divide both sides by 360 and you come up with k equals a negative 1. Since it's a whole number, we got negative 1, it means they are coterminal. This negative 1 tells me it's negative 1 full rotation. 1 negative full rotation. If this was negative 2, it'd be negative 2 full rotation. So this is 1 full rotation. I'll put negative 1 full rotation. So it is coterminal. Which method's easier though? Subtracting 360 or doing this? And maybe they're both the same for you. I'm just saying there's multiple ways to do it. I'm not going to, on the test, make sure you wrote K's and do it this way. If I was taking a test and it was this close, I would subtract 360. And if it comes out to this, coterminal. If not, not coterminal. Alright? So pick the easiest method for your situation. If I gave you one that's, and I won't, that's a hint, I won't give you one that's like 398 billion degrees compared to 1 degree. In that case, you probably don't want to subtract 360 over and over, but I won't give you those cases. I just want to make sure you understand that 360 degrees is the difference between coterminal angles. Alright, I'm going to use the same method for this one right over here, because this is something you'd see in the book if you're doing the book. So I'm going to say, well, 880 is going to equal 150 plus some number of rotations. All right, if this is a whole number, it's going to be coterminal. If not, then it's not. Continuing down, I subtract 150 from both sides, so we have 730 is going to equal K times 360. Divide both sides by 360, and you're going to come up with a fraction. You're going to come up with 73 over 36. If you plug in your calculator, come up with a decimal. As soon as this isn't a whole number, it's not coterminal. So this is not coterminal. But please, please don't get bogged down in this. I don't want to see this on the test and just have jibber jab after, like I don't understand how to use this equation. Just understand that if you subtract 360 or add 360, they better be full rotations away from each other. Okay? Any questions on this? 360, that's our key. Just some geometry stuff. We won't use this much at all. Complementary, 2 angles added up to 90. Supplementary, 2 angles added up to 180. That's about all I'll talk about that. All right, now we're going to get into degree, minute, seconds. All right, we're going to first start out with something called decimal degree. That's what we've used in geometry. That's what we just used right now. It's kind of like the normal measurement system. So decimal degree is our first one. That is one we were just using. It uses decimals. Like I can have 90.5 degrees. The other one is degree, minute, seconds, which is shortened by DMS. Degree, minute, seconds is a much more precise way to measure angles. It'd be something an engineer would use. All right, when they'd measure pavement and stuff, they don't generally use, well, I need 36.2 degrees on this. They'll use 36, 5 minutes, and 2 seconds. Also, people that use maps will use minutes and seconds. Some of you might have heard when you're doing directions, they use minutes and seconds as well. It's more precise. Degree portion of our degree, minutes, seconds, is just like the degree portion here. It tells me that we have 360 degrees in one full revolution. So make sure I said it the same way. Yeah, in one rotation. So the actual degree portion will be the same no matter which one we do. The only thing that's going to change is our decimals. Minutes. Minutes is going to be 1/60th. It's going to be 1/60th of a degree. Seconds is going to be 1/3600th of a degree, which is based upon the fact that 60 times 60 equals 3,600. All right, let's do some 2 practice problems with this. Degree minute seconds won't show up very often. All right, basically going to show it to you, and then it's going to basically disappear. All right, so if you're stuck on it, it's not a big part of our class at all. We just have to show it because there could be engineers in here that will need it, and you want to see it, and it might show up on a test randomly. All right, my example for the first one. I'm going to put both my examples up because I don't want it to be over here. Is going to be 32 degrees, 5 minutes, and 28 seconds. That is my example. So that is now in degree minute seconds. I want to convert that to decimal degree, which would be the most useful in this class, to be able to see this and just convert it to degrees and works it normally. All right, we're going to carry down the whole degree number. So the whole degree stays put. All right, this guy's going to stay the same. It's going to stay 32. I'm just going to go ahead and carry that down. Then we're going to divide the minutes by 60. We're going to divide the seconds by 3,600. We're just going to add them to the 32. So that's going to look like this. We're going to go plus 5 divided by 60. So that 5 just comes down here. Plus 28 divided by 3,600. And you don't need to calculate this. I will do it all for you. Well, I did it at one point. So we have 32 plus 0.0833 plus, bless you, I think. Is that usual? All right, which will just come out to 32.0911 degrees. And that's just an approximation. All right, that's how specific these can be. This is just an approximation of what this measure would be. This direction is not only the most useful, it is the easier of the 2 methods. All right, when we have to go from decimal degrees to DMS, it's a little more complicated. It's not bad, it just takes a little bit of practice. All right, converting a decimal to degree. Our example is going to be a fun one. 56. Let's finish off that colon. 56.735 degrees. A couple things are going to happen here. First, we're going to carry down the whole degree number. Like I said, your degrees between the 2 should be the exact same. If I start with 56 point something degrees, my end answer in degree minutes should be 56 degrees, some minutes, some seconds, every single time. If your degrees are different between the 2, you did something wrong. So we're going to hold on to that 56. And I'm going to go ahead and shoot that down here. That should be enough room. 56 degrees. Then what we're going to do is we're going to take anything that's in the decimal. So we're going to take that 0.735. And we're going to multiply it by 60. So we're going to take that point and we're going to multiply it by 60. And that's going to come out to 44.1. That 44 right there is now your minutes. These are going to be your minutes. That 44 is going to be your minutes. So you're going to carry that over here, and you're going to say it's 44 minutes. Now all we have left is that 0.1. So we're going to take that 0.1, maybe we'll use green. And we're going to multiply that by 60 again. Which equals 6. That 6 right there is now going to be your seconds. This is the only time you round. All right, this is the time when you round. Obviously, if this is, I don't know, if this comes out to 44.1773355555511, you're going to round that, but bring it down. All right, but this one you're going to round to the nearest whole number. All right, so if this was 6.9, you round it up to 7. Generally, these are all whole numbers. Just make sure you read the question carefully because it will say what it round to. If I don't say anything, I just want whole numbers for all 3 of those. Okay. Before you get started, you can note that your homework is right there. Where do we end? Oh, right now. Real quick, I just want to give you a hint on number. You can look at this real quick. Number 31. That is a negative degree. If it's negative, so if this was negative 32, 5 minutes, 28 seconds, it'd be negative 32 minus 5 over 60 minus 28 over 360. All right? So with negative, if this is minus out here, they all become subtraction. If this is positive, add, negative, subtract. Okay? All right, everyone. Have a wonderful day.
Thank you.
You're welcome. 2 math classes down. Woo! Like 4 or 5 left, right? You're welcome.
Did you say, like, we don't say